You're going to use all of your knowledge about titration and standardization to take this lab test. This is the only information I will give you about the lab test. You will be allowed to ask some questions tomorrow in class, but after that, you're on your own. The experimental objective, or the purpose of this experiment, is to determine the molar mass of an unknown acid by titrating it with a standardized sodium hydroxide solution. The acid that you are using is a solid acid, so you will find the mass of it prior to using your sample. The procedure is fairly simple. You will take your unknown acid and you'll titrate it with a sodium hydroxide solution that you have standardized. You will make sure that you reach the end point accurately. You will then analyze your data to determine the molar mass of this solid acid, and you'll see in a little bit why having a solid acid is going to be much easier for you to analyze. First, you will prepare and standardize a solution of 0.2 molar sodium hydroxide. You will do 2 trials only of this standardization. So you will quickly prepare an approximately 0.2 molar sodium hydroxide solution, and then you will standardize it 2 trials and take an average to get the molarity of your sodium hydroxide. You're going to prepare about 200 to 250 milliliters of the sodium hydroxide solution. You're going to cover and store it for Wednesday, and make sure that you cover it completely so that it doesn't absorb any carbon dioxide from the air. To prepare your acid sample, you will accurately, this time you're going to use the analytical balance, so everyone needs to take their turn using the analytical balance, cross that T, and you're going to weigh out a sample of your unknown acid. You will transfer this acid to a clean Erlenmeyer flask. Make sure that you transfer all of the acid from the weighing dish. Some of the solid acid will get stuck to the sides of the wet flask, so make sure that you wash this down with your wash bottle. Completely dissolve the acid sample in your water and add a few drops of the appropriate indicator to the acid solution. When you're titrating, remember, before the end point, your solution will look like this. At the end point will be a very faint pink that lasts for 30 seconds. If you overshoot the end point, it's going to be this deeper pink, and you may have to repeat more trials than you would like to. So go slow and get a good result. Your quantitative work, which is what this is, requires accuracy. There's no point in doing the lab if you're going to be sloppy in your technique. You need to work very carefully. You need to complete a total of 4 titration trials. You will weigh and titrate 1 sample of acid at a time. You will adjust the acid sample size if necessary. So if you see that the weight amount of solid unknown acid that you pick for your first trial requires too much sodium hydroxide, simply reduce the amount the next time. Still accurately weigh out that reduced mass. To analyze your data, you will accurately record the volume of sodium hydroxide. You will then convert that to the moles of sodium hydroxide using the molarity of the standardized sodium hydroxide. So you first will need to make sure you do the standardization calculation so that you know the actual molarity of the sodium hydroxide that you are using. When you relate your moles of sodium hydroxide to your moles of acid, you will need to know whether you have a monoprotic or a diprotic or a triprotic acid, and all of these acids will be available and will be passed out randomly. When you're doing your calculation, if you have a monoprotic acid, then you know it's a 1-to-1 mole ratio. If it's diprotic, 1 mole of acid requires 2 moles of sodium hydroxide. If it is triprotic, 1 mole of acid requires 3 moles of sodium hydroxide. Certainly these calculations take a little more thinking, and here's a general basic equation for balancing these. You might want to write these down in your notebook and bring them with you to class, and you certainly can use them. Again, this is the typical H2A standing for the diprotic acid and H3A standing for the triprotic acid, and you can see the balanced equation requiring 2 moles and 3 moles respectively of that base. Once you have solved for your moles of sodium hydroxide, so again, here's a typical equation. If you had a diprotic acid, you would take your volume of NaOH that you used. Right now they're showing it in liters, but it just as easily could be in milliliters. This is your molarity of your NaOH. Then your mole ratio between the NaOH and the acid. Even if you have a monoprotic acid, you still need to show this mole ratio. More likely, though, you will be using the MaVa is equal to MbVb calculation, which you can also do with the di and triprotic acids. You just need to make sure you take into account the different moles of acid or base. To finish up your calculation, once you have the moles of acid that you titrated, you will divide that into the mass of acid that you weighed out originally, and grams divided by moles is molar mass. So you will do 4 trials and get an average molar mass. You will be graded on how close you are to the true value, so you will be graded on your accuracy. You need to be within 5% of the actual molar mass in order to get an A.